Okay, now we start the triangle problems. So really this is 1, 2, 3, 4, 5 separate problems. And we'll do one at a time, but the information, say for 35, gives us an alpha that we have to take care of. So we're going to use a picture within the XY axis to denote the sine of alpha. Actually, to denote the angle alpha, and then sine of alpha is how we're going to label everything. And the same thing with beta. So we're going to need to draw a picture again for each of these. So I have an alpha angle and a beta angle. Now notice it says alpha is between 0 and pi over 2. So when we draw our angle, we need to draw it between 0 and pi over 2. So that's going to be in the first quadrant. Then we always come back to the axis. So there's our angle alpha. And sine is always opposite over hypotenuse. Or you can say it's y over r. So the opposite is 3, and your r value is 5. So I need to find the missing side right here. You could use the Pythagorean theorem or recognize this is a 3, 4, 5 perfect triple. But that's the missing side. It's positive because it's in quadrant 1. So now we're working with drawing the angle beta. Notice this pi over 2 is less than beta is less than pi. So here's pi over 2, here's pi. So we must be talking about the third quadrant. Now beta is actually this angle out here, but we can use reference angles and get the same value. Notice I drew alpha, beta, okay? And sine is still opposite over hypotenuse, or you could say it's y over r. So the opposite to this angle beta is 12. The hypotenuse is 13, and we need to find the missing side. Now this may very well be a perfect triple too. Let's find out. So you've got x squared plus 12 squared is equal to 13 squared. So I have x squared plus 144 is equal to 169. I subtract 144, so x squared is equal to 25, and x is equal to plus or minus 5. Be careful, and in this picture it's actually negative 5. Now these two triangles, the alpha and the beta, apply to all 5 of these problems. So I'm just going to do these problems one at a time. First we're going to take a look at sine of alpha plus beta. Okay, so we have to write the formula down. That's sine of alpha cosine of beta, and then plus cosine of alpha sine of beta. Okay, so sine is the alternating sum formula, and the operation of plus remains. So sine of alpha, I need to look at my alpha picture. So sine is opposite over hypotenuse, or you can think y over r, but it's given, so we already know what it is. It's 3/5. Cosine of beta, I need to look at my second triangle. Again, opposite over hypotenuse, so 12 over 13, but also that information is given, plus cosine of alpha. Okay, so back to my alpha picture, that's adjacent over hypotenuse, or x over r, so 4/5, times the sine of beta. Okay, so the sine of beta, and we've already accidentally I used right over here. I did cosine of beta. So sine of beta is 12 over 13. Let's fix this. Okay, so back over here. That is incorrect. Cosine of beta. Okay, here's my beta picture. Cosine is adjacent over hypotenuse, and hopefully you caught that as you were watching me do the problem. I just jumped in there too quickly. So I think I'm good. Let me check one more time. So sine of alpha is 3/5. That was given. Cosine of beta is negative 5 over 13. That was not given. Then cosine of alpha is 4/5. Yes. And then sine of beta was given as 12 over 13. Okay, I think we're good now. 3 times negative 5 is negative 15 over 5 times 13 is 65. Now that'll reduce, but I don't want to because I won't have a common denominator potentially anymore. So 5 times 13 is 65 there. 4 times 12 is 48. And then you add your negative 15 and your positive 48 to get 33 over 65. And I believe both of those divides up by 3. I know 33 does. So 65 divided by 3 is 21. No, it does not divide by 3. I looked at that wrong. So I think we're done with that one. 33 over 65 is it. So now what I want to do is keep my triangles, but I'm looking at question B now, cosine of alpha minus beta. All right, so formula for that will be cosine of alpha, cosine of beta, change the sign, plus sine of alpha, sine of beta. So cosine of alpha, I need to look at my alpha diagram. Cosine is adjacent over hypotenuse, so that's 4/5, times cosine of beta, so that's going to be negative 5/12, plus sine of alpha, okay, that's 3/5. It was given, but you could also look at the picture, opposite over hypotenuse, and sine of beta, also given, 12 over 13, but you can look at your picture, opposite over hypotenuse, okay? And now we multiply. 4 times negative 5 is negative 20, over 5 times 12 is 60, plus 3 times 12 is what, 36, over 5 times 13, we've got an issue. Wow, I have another problem. Okay, so cosine of alpha, so looking at my alpha picture, that's 4/5. Cosine of beta, that's negative 5 over 13. You know how I found that error? I think I'm just getting too tired to do these. How I found that error is that usually these denominators match. I've never run into a place where they didn't. So this is not going to be 60 at all. It's going to be 65. So let's get rid of that. Alright, and then 3 times 12 is 36, over 5 times 13 is 65. And now I add my like terms, so that gives me a positive 16 over 65, and I do not believe that will reduce. Alright, so I'm going to get rid of this one, then we're going to come back and do part C. Alright, so part C, tangent of alpha plus beta. So the formula for that is tangent of alpha plus tangent of beta divided by 1, change the operation, minus tangent of alpha times tangent of beta. Let's plug in. So alpha, I'm going to try to be extra careful this time. So alpha is opposite over adjacent, so tangent of alpha is 3/4, plus tangent of beta, so I'm looking at the beta diagram, opposite is 12, over adjacent is negative 5, so it'd be negative 12/5, divided by, okay, and then the formula says 1 minus tangent of alpha, which is 3/4, times tangent of beta, negative 12/5. Now we need to simplify this all the way down, so I'm going to need a common denominator to add these fractions together. That common denominator would be 20. Okay, so I need to multiply this guy by 5 over 5, and then this guy by 4 over 4, and that's going to give us the 20 that we need. So that's going to give me 15 over 20 minus 48 over 20 divided by, okay, in the denominator here I've also got a 20, so I'm going to go ahead and write this guy as 20 over 20 minus, and then 3 times the negative 12 is going to be negative 36, so that's going to make that plus 36 over 20. I keep going, so 15 minus 48 gives me negative 33 over 20. Divided by 20 plus 36 will be positive 56 over 20. My next step is to take my numerator, negative 33 over 20, and multiply it by the reciprocal of the denominator, which is 20 over 56. The 20's cancel, so I get negative 33 divided by 56, and I do believe that is lowest terms. Okay, so next we're going to erase this one and then do part D. Alright, now for part D, sine of 2 alpha. So I need a formula for sine of 2 alpha. And the formula is 2 sine of alpha cosine of alpha. And so that's going to be 2. My sine of alpha was given to us as 3/5, or we could calculate it again by opposite over hypotenuse or y over r. Cosine of alpha, so I'm looking at the same picture, is going to be adjacent over hypotenuse or x over r. Multiply all this together, so 2 over 1 times 3 is 6 times 4 is 24 over 5 times 5 is 25. Okay, and then our last one will be cosine of beta over 2. So now I'm going to go ahead and do this one. I don't see the need to erase the other one. Okay, here we go. Let's try purple. So we need a formula for cosine of beta over 2. And that is plus or minus, it's part of the formula, the square root of 1 plus the cosine of beta over 2. Okay, so that's the half angle formula. And that gives me plus or minus. We're not going to handle the plus or minus until the very end. 1 plus, and then the cosine of beta is going to be adjacent over hypotenuse. So negative 5 over 13 divided by 2. Now our problem is we need to combine these fractions together. So I'm going to multiply by a unity fraction to get a common denominator. So I'm going to multiply this by 13 over 13. And that gives me 13 plus a negative 5. Well, don't forget about the plus or minus square root. But 13 plus a negative 5 is 8 over 13 divided by 2. And that's 2 over 1. So it gives me plus or minus the square root of 8 over 13 times 1/2. This 2 and this 8 cancel, give me a 4. So that's plus or minus the square root of 4 over 13. Well, the square root of 4 is 2. So that's plus or minus 2 over the square root of 13. And then we should rationalize. So that's plus or minus 2 square root of 13 over 13. Now I've got to decide again, is this positive or negative? And I'm looking at beta. Okay, now if you take half of any angle over here, let's think about it. Like the smallest an angle in quadrant 3 would be just above 90 degrees. Half of that would be 45. It would take you in the first quadrant. The biggest it could be is just below 180. Half of that would be just less than 90. So again, takes you back to the first quadrant. Cosine in the first quadrant is positive, so the only one that matters is the plus 2 square root of 13 over 13. Alright, so we have another one of these problems, the triangle problems, but we have 5 different questions to answer again. I need to draw a triangle for tangent of alpha is equal to 4/3. It tells me that pi is less than alpha is less than 3 pi over 2. In other words, the angle alpha is between pi and 3 pi over 2. We're talking about right over here, okay? Let's draw that in red. Then you go back to the axis. Now, the angle alpha really starts at the positive x-axis and rolls around, but we can label it with just its reference angle. And then we use tangent of alpha is 4 over 3, so the opposite over adjacent, so opposite is 4, over adjacent is 3. Now, my thought is that correct? Well, no, you're in quadrant 3. They actually have to both be negative in quadrant 3. So again, the y over x or opposite over adjacent, both negative in quadrant 3. We can find the missing side using the Pythagorean theorem, and I'm sure you trust me that it's 5. Okay, now let's draw beta. Okay, it says 0 is less than beta is less than pi over 2. So that's in quadrant 1. I draw an angle in quadrant 1, and this is beta, whereas I didn't label this, but this is definitely alpha. Alright, and I need to label beta. It says tangent of beta is 5 over 12. So again, that's opposite over adjacent, or y over x. So my y value is 5, my x value is 12. We have to find the missing side. So that work would be 12 squared plus 5 squared is equal to c squared, or r squared. It's 144 plus 25 is c squared. So that's going to be 169 is c squared. So c is plus or minus 13 when you solve the equation, but c, or r up there, is always positive. Okay, so your r value is always positive. Now, let's actually start doing these problems. So I'm looking for a sine of alpha plus beta. The place to start is to write the equation for that. So that's sine of alpha cosine of beta plus cosine of alpha sine of beta. So remember, sine alternates and you keep the operation. So sine of alpha, so I need to look at my alpha picture, and that is opposite, which is -4, over hypotenuse, which is 5. My beta picture, okay, so that's going to be adjacent, because its cosine is 12, over my hypotenuse is 13. Plus cosine of alpha, I need to look at my alpha picture. So that's adjacent, which is -3, over hypotenuse, which is 5. And then my beta picture, so sine is opposite, 5, over hypotenuse is 13. So now I multiply, I get -48 over 65 plus a -15 over 65. I add a -48 and 15 together, and I get a -63 over 65. Okay? Alright, next problem. We're supposed to find cosine of alpha minus beta. So the formula for that is cosine of alpha, cosine of beta, and then you change the sign. So this is going to be plus sine of alpha, sine of beta. Now we plug the information into our formula. So I go to my alpha picture, and the cosine is going to be -3 over 5. Again, that's adjacent over hypotenuse, or x over r. Cosine of beta, I go to my beta picture. So adjacent over hypotenuse is 12 over 13. Plus sine of alpha. So the sine of alpha is going to be opposite, which is -4, over hypotenuse, which is 5. Sine of beta, let's look at my beta picture. So opposite is 5 over 13. I multiply, that's -36 over 65 plus a -20 over 65, which is a -56 over 65, and I don't see that that reduces. So next I'm going to erase both of these and then work on C, tangent of alpha plus beta. Alright, now let's take a look at part C, tangent of alpha plus beta. So the formula for that is tangent of alpha plus tangent of beta over 1 minus tangent of alpha times tangent of beta. And I plug into the formula. So tangent of alpha we were given actually in the very beginning, that's 4/3, plus tangent of beta. So tangent was given also, that's 5/12. But now you should be able to look at your triangle and still come up with 5/12 because it's opposite over adjacent. So we're good. And then 1 minus tangent of alpha we've already looked at, that's 4/3 times tangent of beta, which is 5/12. Now we just simplify this expression. So I'm going to come up here. I need a common denominator, and that's going to be 12. So I'm going to multiply this by unity fraction of actually 4 over 4. Okay, so 4 over 4. And that's going to give me, 4 times 4 is 16/12 plus 5/12. Oh, just a second. And then divided by, now I still have a common denominator issue here as well. I'm going to multiply this fraction of 1 by 12 over 12. Oh, it shouldn't be. It should be, we can reduce this, but it's still not going to be 12 over 12. Just a second. Now this 4 and this 12 will reduce to leave a 3. So my common denominator there is 9. So we could multiply this by 9 over 9. So we'll have 9 over 9 minus, and then that's 5 over 9. If I keep going, that gives me, in the numerator, 21/12 divided by denominator 4/9. So I got 21, that equals 12 times 9/4. And here, that'll be 3 and that'll be 4. So 21 times 3 is 63 over 4 times 4 is 16. So tangent alpha plus beta is 63 over 16. So now I'm going to erase this, and then we'll move on to sine of 2 alpha, or part D. Okay, now we're ready to attempt D, or the sine of 2 alpha. Okay, so this formula for sine of 2 alpha, there's only one formula. It's 2 sine of alpha cosine of alpha. Alright, so that's going to be 2, the sine of alpha, again, is going to be y over r, so -4/5, or you could say opposite over hypotenuse, and cosine of alpha is adjacent over hypotenuse, or x over r, so -3/5. I multiply this together, so that's going to be 2 times the -4 is -8, times the -3 is +24/25. Okay, the next thing I want to do is the last problem on this page. We're going to evaluate the cosine of beta over 2. So I need a formula for that. So you can look that up. That's plus or minus the square root of 1 plus the cosine of beta, all divided by 2. And just make sure, double check that's right. I'm comfortable with that. So that is plus or minus the square root of 1 plus, now the cosine of beta, cosine is x over r, 12 over 13, or adjacent over hypotenuse, which is still 12 over 13, divided by 2. Notice that 2 is underneath the square root as well. Now I need a common denominator to add this numerator together. So I'm going to multiply this 1 by 13 over 13, and that gives me plus or minus the square root of 13 plus 12. This is going to be 25 over 13 divided by 2 over 1. Come up here and finish. That's plus or minus the square root. So that's 25 over 13 times 1 over 2, which is plus or minus the square root of 25 over 26. Now, the square root of 25 we know is 5, so that's plus or minus 5 over the square root of 26. Then we could rationalize by multiplying the square root of 26 times the square root of 26. So I have plus or minus 5 square root of 26 over 26. Now the question is this positive or negative? Now we're looking at beta. Beta's in quadrant 1. So half of beta would also have to be in quadrant 1. You agree? I mean, this guy right here has to be. If you cut that angle in half, it's still in quadrant 1. All trig functions in quadrant 1 are positive. So the answer is definitely the positive 5 square root of 26 over 26. So we've got a brand new triangle problem to do. So I need to draw an angle for a triangle for alpha, and then a separate one for beta. This story right here tells me that alpha lives between pi over 2 and pi. So here's pi over 2, due north, and pi due west. So somewhere in between there is our alpha. So always come back to the axis. This is the angle alpha. This says tangent of alpha is -3 over 1. Remember, tangent is defined to be your opposite over adjacent, or y over x. Okay? Now, it's 3 over 1. You can't take the negative with the 3 in this case because y values are positive in quadrant 2. So this is 3 and this is -1. And we'll have to find the missing side, which is your hypotenuse. So you got -1 squared plus 3 squared is equal to r or c squared. 1 plus 9 is r squared. 10 is r squared. So r would be plus or minus the square root of 10, but r can never be negative, so just the square root of 10. Okay, let's do something similar for our beta. Now beta is between 3 pi over 2, which is due south, and 2 pi, which is due east. So I'm going to draw an angle in quadrant 4. Okay, so there's the reference angle beta. And it says cotangent. Now cotangent is defined to be x over r. So our x value and our r value, so negative 3 over 1, but x in this case is not negative. It's 3, and it's the y value, not r, the y value that is negative 1. Okay, so we need to find the hypotenuse. So that's going to be negative 3 squared, positive 3 squared, plus negative 1 squared is equal to r squared. Again, let me make this clear, okay? So the negative either goes with the numerator, like this, or it goes with the denominator, like this. But since we're in quadrant 4, the x value is not negative. It has to be this situation. So that's a positive 3 over a negative 1. I want to make that clear. All right, so we got 9 plus 1 is equal to r squared. So 9 plus 1 is 10 is equal to r squared. So r is equal to the square root of 10. It's really plus or minus, but that has to be the positive square root of 10. Alright, so now that we've got our triangles drawn and all the sides are labeled, we could start working with our trig functions here and try to evaluate this exactly without using a calculator. Okay, so, and there is a way you could do this with a calculator, but you're not going to get exact values, like always. Now, I'm doing sine of alpha plus beta. So that's formula is sine of alpha, cosine of beta. Keep the same operation, which is plus cosine of alpha, sine of beta. And then I just plug directly in. So sine of alpha, okay, is, and then you're doing opposite over hypotenuse. So this is going to be 3 over the square root of 10. Cosine of beta, look at my beta picture. Cosine is adjacent, which is 3 over hypotenuse. So that's also 3 over the square root of 10. Plus cosine of alpha. So cosine is adjacent over hypotenuse, so negative 1 over the square root of 10. And sine of beta is opposite over hypotenuse, so negative 1 over the square root of 10. This one's interesting. So 3 times 3 is 9. Square root of 10 times square root of 10 is 10. Plus, that's going to be a positive 1. Square root of 10 times square root of 10 is 10, which gives me 10 over the common denominator of 10, which is just equal to 1. Then we can squeeze part B on this page. And so my formula for cosine of alpha minus beta is cosine of alpha, cosine of beta. Cosine, the operation changes to plus, sine of alpha, sine of beta. So cosine of alpha, look at my alpha picture, that's adjacent over hypotenuse, so negative 1 over the square root of 10. Cosine of beta is also adjacent over hypotenuse, but looking at the second triangle here, the blue one, that's going to be positive 3 over the square root of 10. Plus sine of alpha, back to my red triangle, so sine is opposite 3 over the square root of 10. Times sine of beta, so I'm looking at my blue triangle, opposite negative 1 over the square root of 10. And I simplify, this is negative 3 over 10 plus a negative 3 over 10, which is a negative 6 over my common denominator of 10, which is negative 3/5. So what I want to do now is erase the screen, leave my triangles up, and then we can work on C, then D, then E. Alright, so we're ready to calculate C, tangent of alpha plus beta. We need a formula for that. So it's going to be tangent of alpha plus tangent of beta divided by 1 minus, always change this operation, tangent of alpha, tangent of beta. So plugging in, tangent of alpha, I'm looking at my alpha picture, it's actually given, it's negative 3, plus tangent of beta, that's not given. So tangent is opposite over adjacent, or y over x, so negative 1/3. Now, it is somewhat given because it gave you cotangent. You could just flip that reciprocal. Over 1 minus tangent of alpha was negative 3 times tangent of beta we calculated as negative 1/3. And we need to just simplify this. Now, I need to add these two fractions together, so I need a common denominator, which is 3, so I got to multiply this guy by my unity fraction, 3 over 3. Okay, so it's going to give me negative 9 thirds plus a negative 1/3 divided by, now here the 3's cancel, and you've got a negative times a negative times a negative, which is a negative, so you're going to have 1 minus 1. Really? So 2 negatives, I've still got a negative, and the 3's cancel. Okay, so that's a little bit of a problem, don't we think? So that continues on to give me, negative 10 over 3 divided by 0. What does that mean my answer is? Well, it makes me want to check my numbers again and make sure it's right. But the answer is undefined. I guess it does happen, right? The answer is undefined whenever you divide by 0. All right, so what I want to do is clear this out and then work on sine of 2 alpha and then cosine of beta over 2. All right, so next we're going to do a d, sine of 2 alpha. All right, so we need a formula for sine of 2 alpha, and that formula is 2 sine of alpha cosine of alpha. If nothing else, this repetitive will definitely help you learn the formulas, and you will know how to plug in for them. So this is dealing with just the alpha triangle. So it's going to be 2 times the sine of alpha. So sine is opposite over hypotenuse, or y over r. So that's going to be 3 over the square root of 10 times the cosine of alpha. So same triangle. That's going to be adjacent over hypotenuse, or x over r. So negative 1 over the square root of 10. Then you simplify. This is 2 over 1, so 2 times 3 is 6 times negative 1 is negative 6. Don't forget to multiply the square root of 10 times square root of 10, which is square root of 100, which is 10. And then reduce this to lowest terms. So negative 3/5 should be your answer there. All right, so now let's try the next one, which is our last one on this page, cosine of beta over 2. So we need a formula for that. We need a different colored pen. So we got plus or minus the square root of 1 plus the cosine of beta divided by 2. So it's going to be plus or minus the square root of 1 plus, now the cosine of beta, so you're talking about your x value, which is 3, over your r value, which is the square root of 10. Or you could think about it adjacent, which is 3, over hypotenuse, which is the square root of 10. And don't forget to divide that by 2. We need a common denominator to be able to combine these together. So I'm going to multiply this guy by the square root of 10 over the square root of 10. Okay. And that's going to give me plus or minus the square root. This is going to be the square root of 10 plus 3 over the square root of 10, all divided by 2 over 1. Invert and multiply. So I'm going to come up here and continue, plus or minus the square root. So this is going to be the square root of 10 plus 3 over the square root of 10 times 1/2. Okay, so that gives me plus or minus. Now I can't add the square root of 10 plus 3. I can rewrite this as square root of 10 plus 3 over 2 square root of 10, but then I still need to rationalize. Okay, you've got a square root and a square root, which is also a weird thing, but it does happen. So I'm going to multiply by the square root of 10 over the square root of 10. So it gives me plus or minus the square root of. Now when I distribute this square root of 10 times this square root of 10 is 10, plus 3 square root of 10 over, and then this square root of 10 times square root of 10 is 10 times 2 is 20. And I believe that's about as simplified as it'll get. We do need to reduce if we can, and we need to decide, which we can, I don't think, and then we need to decide whether our answer is positive or negative. Now remember, we are in quadrant 4. So half of quadrant 4, you got to think about where is that going to take you. Half of quadrant 4, because we're doing beta, which is in quadrant 4 divided by 2. Now if it was up to 360, half of that would take you to back to 180. Okay, and then 270, half of that would be even less than that. So you're actually talking about over here in quadrant 2. And then cosine is what kind of value in quadrant, well, it's an x value no matter what. But the question is it positive or negative in quadrant 2? And cosine's negative. So the answer to me ought to be negative square root of 10 plus 3 square root of 10 all divided by 20. Even the square root of 20 can be broken down as 2 square root of 5. So that 1/2 could come out front. So maybe we should do that. So I'm going to break this down again as the square root of 4 times square root of 5, which would give me negative. And then in the numerator we'd have 10 plus 3 square root of 10 over, in the denominator we would have 2 square root of 5. And that could even still be rationalized. This would just go on forever. I'm happy if you get, right down here.